All right, we're going to continue on. We're going to do another one where we have a horizontal and vertical shift, but now we're going to look at a cosine. It's the next one, number 14. Remember, the very first thing you should look at, do you have a vertical shift? In this case, this -3 is a vertical shift, so that tells me that's going to be the point that's exactly in the middle of the cosine wave. That's our equilibrium of -3. Now, to get the max, get the max in the min, I have to use the amplitude. The amplitude here, and I always take the absolute value of this. That's -1, so I take the absolute value of it. It's 1. So to get the amplitude, to get the max, I add the amplitude to the equilibrium. So when I add 1 to -3, I get -2. To get the minimum, I take away the amplitude from the equilibrium. So -3 minus 1 gives me -4. Right off the bat, I know these are the 3 y values. Remember, it's always the hardest part to get the x values. Let's get the easy part first. Okay, if we can continue on, period is 2 pi divided by b. B is this case, it's 1/2. Now, if you divide by 1/2, that's the same as multiplying by 2. So 2 pi times 2 is 4 pi. So I'm going to stretch this out horizontally. Okay, the start. Well, this is going to be, since it's a minus on the inside of the parentheses, I'm going to shift this cosine curve to the right. So it should be to the right of 0. Now, to check it, I take what's in parentheses, 1/2 x minus pi over 2. To get the starting point, I set it equal to 0. Now, here's a little trick here. Since the bottom number for everything is 2, I want to get rid of the fractions. It gets ugly with the fractions. I'm going to multiply everything by 2. So 2 times 1/2 is just x. 2 times pi over 2, this 2 goes away, so it becomes x minus pi. And 2 times this 0 still gives me 0. So then if you just add pi to each side, you're going to start at pi. And that makes sense. It's positive. I'm shifting it to the right. Now to get the end, we're going to take the 1/2 x minus pi over 2. Now we set it equal to 2 pi. Because that's usually where we end on a normal 1 revolution period that we're looking at. Now I'm going to do the same thing. I'm going to multiply both sides by 2. So these cancel, so it just becomes x. This cancel becomes minus pi. But now this changed a little bit. 2 times 2 pi is 4 pi. And then if you add pi to each side, 4 pi plus pi gives me 5 pi. Okay, this makes sense. This is where I start. This is where I end. The distance between pi and 5 pi equals the period of 4 pi. So we're checking our work as we go. Okay, the increments. I take the period, which is 4 pi. I divide it by 4, because there's 4 intercepts in the unit circle. 4 is cancel, I get pi. So here's the good thing about this. I'm not going to deal with any ugly fractions. Okay, key points. I first get the x values first. The first x value is this pi. And then the increments is also pi, so I keep adding pi to it. So I'm going to have 2 pi. Then I have 3 pi. Then I have 4 pi. And then get the fifth and last point. I add pi to it, and I get 5 pi. Lo and behold, it matches up with that ending point right there. So I have 5 key points. That's the hardest part, doing the whole increments and getting the key points for the x values. This should be the easy part. Okay, cosine, I ask myself, where does it start? Well, it normally starts at the max, but since you have this minimum, everything's going to flip. So I'm going to start here at the minimum. So it's going to start at -4. It's going to go up to the equilibrium of -3, go up to the max of -2, then come back down to the equilibrium of -3, then end at where we started, which was the minimum, which is -4. So this should look like an upside down U. So let's take this and let's graph it. Graphing it is the easiest part. Getting the key points, the hardest part. Alright, so let's say this is pi, this is 2 pi, 3 pi, 4 pi, and 5 pi. Alright, so pi, we're down at the minimum. 1, 2, 3, we're down. This is the minimum at -4. 2 pi, we're at the equilibrium of -3. 3 pi, we're at the max of -2. 4 pi, we're at the equilibrium of -3. 5 pi, we're back at where we started, which is the minimum of -4. So remember, when you connect it, this is what it looks like. I know if I continued, it would just go up like this. We continue forever to the right, continue forever to the left. So that's why our domain is all real numbers, but you only have to graph one period.